table of 0.159. Okay, so these two numbers are the same, and these are the two tails, but actually we were asking for the area in the middle, right? So we need to add these two together and then subtract from 1, because the whole area under the table is 1, right? So when we do that, we get this at the bottom. So we add these two together, they're almost 16%. So we almost get 32%, 0.3173, taken away from 1 gives us 0.6827. So this area is the area in the middle, plus or minus 1 standard deviation. Yeah. Okay.
What does the table exactly give?
The table exactly gives you the areas in the tail regions of the standardized normal distribution, which is what you calculate with a Z value. So you look up a Z value in the table. If you've got a Z, you look up on the left-hand column, and depending on the second decimal place, you will find a number in the table. Okay, so it's just areas. Numbers in the body of the table are areas. The numbers given in the column, the left-hand column, and the top row, okay, the headers of the top row, that gives you the Z value. Let me just go back to clarify, because that may not be very clear to everyone. Okay, so what we have is the Z value here in the left-hand column. I chose 1, 1.0, here's 1.0, but let's say I had 1.1, then I'd be looking down this column here. Okay, and we've got 1.01, 1.02 up to 1.09, and then we go to 1.1, 1.2, and so on. So this is the second decimal place that's given along the top row.
He's asking if bit represents part of the sample.
The sample?
Yeah.
Okay, we're not talking about a sample yet. This student is ahead of the game, so we'll be doing that in a week or two. This is just talking about individual observations taken from a population. Okay, no samples, but interesting question. Okay, so that means approximately, because if we multiply this 0.6827 by 100, it gives us a percentage. 68.3% of the area beneath the standard normal curve lies plus or minus 1 standard deviation from the mean. Okay, so what about plus or minus 2 around the mean? Okay, 2 standard deviations, or Z of minus 2 to plus 2. Okay, well, let's go to this table. It's going to be 2 here again, and 2.0, no second decimal place. And we get a value here in the table, the body of the table. This is the area, which is 0.0228. This is probability. And that's near enough, 0.023. Okay, there it is, tail region that we want. If we subtract, so we've got the middle 2, plus or minus 2, a Z of 2, all right, then each of the tails would be the same above and below, all right? So we need to multiply by 2, so it's 2 times by 0.0228, and then the area in the middle will be 1 minus that, okay? And that gives us 0.9545, so nearly 95% lies plus or minus 2 standard deviations. So here we are, this is what we've calculated in those 2 calculations. Plus or minus 1 is 68.3% in the middle, and we've got 2.3% in the 2 tails, and from plus or minus 2 standard deviations gave us 95.4%. Okay, this is what we got here. So between these 2 red tails is approximately 95%. Okay, so We can work out our Z value, as I said. However, this does assume that the distribution is normal. And this student at the front here asked, well, what about a skewed distribution? That is a problem. You can't actually do the calculations with a skewed distribution. It's going to be approximate depending on how skewed the distribution is. If it's a little bit skewed, well, it's not going to matter too much. But if it's strongly skewed, positive or negative, then you will get wrong answers. So we need to make the assumption of normality. When we come to samples, actually, which is what a student also asked, samples, interestingly, when we're dealing with samples, the distribution of the samples, if the samples are large enough, is very approximately normal. Okay, so that there is a normality assumption that we can make, but I'm going ahead of myself. I'll stick to today's lecture. Okay, so in practice, we can often assume variables are approximately normal, and we can use Z, all right? Okay, so this is from the example that we were doing. We had a mean of 211, standard deviation of 46. So we might want to ask, above what score do 10% of the population lie? Now this is different. I'm not saying what's the proportion above 245. That's working out a percentage. Here I'm giving you a percentage, and I'm saying, well, what's the value here? What's the SCL above which 10% of the population lie? Another way of putting that is if I select someone at random from the population, what would be, if it was 10%, what would that particular value be on that scale? So 10% of the population, what is that score on the SCL? So what we're talking about is this area here. If there's a 10% chance, then what would this value be here? Okay, so how do we do this? Any suggestions?
0.1.
Yes, okay. So what we want to do, because these areas in the body of the table are, these values in the table are areas, percentages, proportions, probabilities, all the same thing, okay? We want to find 0.01 here. Okay, so where is it? Somewhere here, huh? Here, okay, this is the closest one, 0.1003. So it's not exact, all right, but it's close enough for us. It's to within 3 decimal places. Okay, so that gives us 1.28. You see 1.2 here, then the second decimal place is 8, so it's 1.28. That is our Z value. So that means that this point is 1.28 standard deviations above the mean. All right. So this is our Z value, 1.28, okay? And what we need to do then is multiply 1.28 by our standard deviation and add it to the mean, all right, which was 211. So we get 1.28 times by 46. It's important to use the brackets here, all right? If you were to add 211 to 1.28 and then multiply by 46, you would get a crazy number, okay? What you've got to do is to multiply this first in the brackets and then add it to the mean, and we get 269.88. So this point here is 269.88, all right? Okay. So there are some exercises that we could do, and someone was asking about exercises last. There's plenty of exercises, and I think today we will do some exercises in the lab. I'm going to stop the recording now, and I'm going to get the sheets for those who are attending here. Just pause the recording. So I'll go and get those and be back in a minute.